This may not look like an important piece of medical equipment, but it could be one of the critical things keeping COVID-19 patients alive. It's an emergency ventilator designed by a team from MIT that is trying to use common equipment, both medical.
We want to use one of these Ambu Bag things to ventilate people.
And automotive.
Windshield wiper motors are one of the most engineered things on the planet.
FDA-approved ventilators are sophisticated machines that cost roughly $30,000 and require hundreds of components. The MIT team took that as a challenge. Design a low-cost ventilator that could be built anywhere there's need. They put their research on an open-source website so that groups around the world adapt it to what they had locally and give feedback. We spoke with research scientist Nevin Hanumara and professors Alex Slocum and Daniela Roos.
The idea that we could attach a robotic device that is easy to manufacture, low cost, robust, and gentle to the bag is what guided our work.
The design can be broken up into three main parts: the breathing circuit, the mechanical ventilator, and the controls. The breathing circuit is made up of supplies that hospitals already have on hand.
We refer to it as the manual resuscitator bag, the breathing circuit, and the endotracheal tube.
The heart of the design is the Ambu Bag, a very common piece of equipment in hospitals. It's a manual respirator usually squeezed by trained medical personnel to push air into the lungs of patients temporarily.
You can't have one responder per patient squeezing one of these Ambu Bag things to ventilate people. So we need a little box to do that automatically.
Ambu Bags are common life-saving equipment, but they aren't designed for long-term use. Keeping the bag from wearing out too quickly was the first challenge. The team needed to be able to use them for weeks, just like the electrically powered ventilators usually used by hospitals.
And the general theme is be nice to your bag. Because if this thing that's normally meant to just be squooshed for an hour has to do for 2 weeks, you don't want to break it.
To do that, they had to build a pair of gentle yet robust robotic hands.
That curved shape of the hands or the paddles that gives us that nice gentle rolling to keep the center of the bag happy.
Originally, the idea was to have a design that could be created in makerspaces around the world. But they soon discovered the machines would need far more industrial materials if they were going to keep COVID-19 patients breathing. Their first prototype used laser-cut plastic for the hands. That plastic is fine for hobby projects, but it quickly failed when tested.
This makerspace laser-cut plastic is no good. You need to design this thing so you could kick it across the room.
The solution? They reinforced the hands with metal. Strengthening the robotic hands was an easy design fix. Now there was a new problem: the increased load on the machine's gears and motors. Their first design relies on a single motor turning 2 gears.
The gears engage each other, so if you move one hand, the other hand will be forced to go with it. And it works great. It's a fine thing, but the gears are highly stressed when you get to these big loads of the COVID patients.
To fix this problem, the team is exploring a new idea, using 2 motors to control the 2 hands separately. They found a possible solution in an unlikely place: the front of nearly every car on Earth.
We're using windshield wiper motor, one of the most engineered things on the planet. I mean, they're designed to go, well, you know what they do. You can beat the tar out of them. It's easier in places around the world to grab 2 wiper motors, because the ones we're using are nearly ubiquitous, than to require relatively good manufacturing to get the gear design to work.
However, as the designs continue to evolve, the control aspect of the machine becomes more and more important.
If you have 2 motors, now the software has to ensure that the 2 motors are well synchronized, because otherwise if one arm pushes and the other one forgets to come in to help, you don't really have a working system.
After consulting with doctors, a few necessary requirements became clear. One of the reasons ventilators work is because they give healthcare workers fine control over the volume of air pushed into the lungs, how many breaths per minute, and the ratio of inhale to exhale. So the team built a control board that works like a retro stereo with big turnable knobs.
Even though in a very simple design, what's the minimum information we need so that someone who's respiratory trained can make the necessary adjustments
They also had to include critical alarms that would go off if the pressure in the lungs was too much or too little.
The doctor doesn't care about the guts of the machine. The doctor just wants to adjust the knob and then... So that's where you have this balance between mechanical complexity and control complexity.
Recently, the team consulted with 10x Beta in New York to create 3,000 ventilators called the SpiroWave, and many teams around the world are building similar prototypes. As COVID-19 spreads, the team wants to make sure that this design can be used in local supply chains, especially where it might be difficult to access normal ventilators. The website provides an interface for people to leave feedback and learn about what could work for their own markets.
There's many different mechanisms you can envision as people are and will. The things that are the same will be the forces, the alarms that are needed, these functional requirements. And then now it's up to the creative people, which are all over the place. And then they can apply it to what they do have for local production.